Let me get this right place here.
Okay, we are recording.
Okay. Okay, just have to move a couple things around here. Okay, you see that?
Yep.
Okay. Let's see. That's where we're supposed to start. Okay, collections Java represent a single unit of objects or group. Uses the java.util package. Contains all the classes, interfaces for the collection framework. And there's a hierarchy of collection framework. There it is. So basically everything that's blue is an interface and the greens are classes. Like DQ is extends the queue interface, and let's see. So collections is a pretty big and awfully long, there are a lot of stuff you can learn on that, like he explained earlier. But I just thought I'd show you some of what I have. I just threw together some things. The list collection. I'll just run this first. So the list collection will just list everything that I have. And you notice I have fudge swirl on here twice. It'll just put everything same order and do it exactly as you have it. But then I sorted it to put it into reverse order and alphabetical reverse order, which starts at vanilla and goes all the way down to bubblegum. And then you have the set collection. You can basically find a lot of things a lot faster with the set collection. You notice that I asked it here if it contains chocolate to to print out chocolate is found in the list. So it finds that pretty quick. And then it does everything in order. And something with set collection is there's no duplicates. It doesn't accept duplicates. So there's only one fudge swirl in this one. And then the queue, I've done a priority queue, and I used peak right here to get the head of the queue, which is bubblegum. And then it prints out everything. Use the iterator to print that. The second queue collection I have, I did a try catch, and I guess that's something for this week, isn't it? But yeah, I'm using an array blocking queue, which you can set the capacity. It has a set capacity. which is fixed. But I've put 3 in, but I did a catch exception, and it tells me that you're over the capacity of the queue. So it didn't print anything out except that. My third queue is going to demonstrate another array blocking queue, but this time I did the capacity of 3, but I have 4. I used, instead of using add, I did .offer. Offer allows you to go over this capacity, and it won't give you an exception. So, and then there's a spork in here, and it'll print out, so it did right here. And then when I do print it, it brings up just the 3, because the capacity is only 3. But it won't do an exception because it's not .add. So offer is a better one to use in that situation. Well, probably better most of the time. And then the map, I'm using hash map. And this one has let's see, where am I? So it has key value and keys. So I have them all here in order except for the bottom one. I have 3. Pineapple is 3. And when it does print out, it's going to print out pineapple as number 3 over here. So it is nice. You can put it in any order you want there, and it'll print it out according to the key.
The key isn't the same like the index number.
Yeah, the index. You're right here, the number.
But it's not the same, or it's the same? Because I suppose that every collection or array start with index 0. So do you?
Oh, yeah. I think you can put your key as I believe you can put it as ABC. I'm not positive on that. Does anybody else know?
Yeah, you can. You're talking about the keys. You can make those anything you want.
Yeah.
I used a manager name, and then I actually used an array of salesmen for the value that the key is mapped to.
Oh, okay.
So you can do stuff like that.
Yeah, that makes
But
sense.
as far as indexing through it, I'm not exactly sure how you do it, because I use the get key and get value methods that are within the map method that I used to return the key and the value. So I don't know if you index through them the same way. It looks kind of like maybe you did down in your for loop there.
Yeah.
So but it looks like all you're doing there is just running the key, right? Map.
Yeah.
Oh,
yeah.
no, maybe not. Maybe it looks like you're indexing through it because you got map.get, not get key.
Yeah.
So yeah, I think so, Carlos. I think you can index through it, but it's gonna be index 0, but it's not gonna be. So index 0 is key value 1, and
and that's true.
Or key 1 and then value of Rocky Road.
Yep.
I think.
Yeah, I think it would be. And this last in here, I have. I like this too. You can do map.size. It'll give you the number. So just count how many there are and give that to you. Kind of handy.
Oh, hey, Mitch, I have a question.
Yeah.
It says that your number of flavors is 11, and does that go directly with your list there? It does. So
yeah,
you actually have 12 entries, but pineapple just replaces vanilla, and you end up with 11, right?
Yeah.
Cool.
So it replaced it. Yeah, I forgot to bring that up. Sorry.
I think you did. I just wanted to see if 11 was the real size, and yes, it is.
Yeah. And then I did a list using generics, created the location over here. It's kind of sweet because when you add, you have it already set up. So then when I do see, it already starts telling you, asking for that because I've linked it with location. Let's see. So, and then that just prints out like this. So probably muddies all the waters, but you guys probably should have yours turned in already though. That's basically how I understand collections. So any questions?
No.
Nope.
It's clear.
Can I ask you guys a question? It's including you, Mitch, of course, since
Okay.
you're the one leading the discussion here. Can we look at that hierarchy picture that you had, where it showed the collections hierarchy?
Yeah.
Okay, so in my reading, I read somewhere that it said linked list is an implementation or can be an implementation of queue. So is that right? Does that corroborate with your diagram here?
I think so because
Let's
it's
go
linked
there.
with DQ, which is linked with Q.
Huh, okay.
I'm guessing.
Okay, looks right. So technically linked list is a implementation of queue.
Yeah.
Cool. Very good. Thank you, Mitch.
Yeah, these were, I don't know, it's hard for me to wrap my head around all these. Like I said, you can dig into these quite a ways.
Yeah, I'm the same way.
All right.
All right, is that it, Mitch? Uh-oh. Did
That
we lose
is.
Mitch? Oh, no,
Yeah.
you're here. Okay, you're still here.
All done.
All right, cool. My turn?
It's all yours.
Okay. Let's see what damage I can do here. Can you guys see my little PowerPoint here?
Yeah.
Okay.
Yeah.
So we'll just dive right in. So here's some things we're going to go over. Types of, when talking about exceptions, types of errors, situations that you might use exceptions and exception handling, and some options that Java gives you with dealing with the exceptions. Then in data validation, we're going to talk a little bit about what data needs to be validated and some options for performing that validation. So here I've got two websites that I've kind of used to base all my claims here. If you guys have anything you want to add, or if I'm missing something, I don't, I'm not an authority on all this. This is just how I understand it so far. And honestly, I haven't had very much time to research the various options on data validation, like this article in that was part of the reading for this week, the Java tips on handling validation in an elegant manner, which is a very interesting article. I just haven't quite wrapped my head around it yet. And that's actually listed right here. So Okay, moving on. Types of errors. We got compiler errors, and they're going to have to be dealt with before a program will even execute. So the compiler will say, no, you can't do that. You can't, I'm having an error running I'm having an error compiling the program. Then we got checked exceptions, and that is classes that inherit the throwable class, and the compiler actually checks to see if those are handled. And if it's not, it won't let you run the program. So it's not a compiler error, it's just a compiler checking to see if that exception is handled. Then we have unchecked exceptions, and that's where for any class that inherits the runtime exception. And so right there, you know, what we're talking about is runtime errors. The compiler isn't going to force you to handle any of the exceptions in order to run. So you can run it, and if it comes up with this problem, it's going to throw, you're going to have to deal with the exception. So here's some situations that where you might use exceptions. Wrong data was entered by the user, network connection problem, hardware problem, opening a file that isn't available or doesn't exist, like server down, stuff like that. So here's some options for handling exceptions. Is a try catch block. That seems to be a pretty standard way that Java offers to do this. This is the basic syntax, and we can look at an example in a minute. You know, try, then you put your code here, and then the catch, if it throws the exception, you can put your error message there that can be displayed. And you can also put other code down here too on how to handle it. Then there's the throw keyword, and you can put that explicitly in your code direct, as where you don't have to use the try catch block. You can do this syntax here, throw new exception. Obviously, if you want to get specific with your exception, there's all kinds of different exceptions. Exception is this word exception is like the most basic exception that Java has. And you can put whatever error message you want. So why don't we go ahead and look at this website here. Here we go. Okay, so this is an example of a checked exception. So like this file input stream, since it inherits this, where is it? Yeah, it throws this file not found exception. So here's the example of that happening. And they've got it in a while loop here. And then here's the error that it's going to put out on its own. You see there's no handling of this exception here at all. It's just doing it. It gives you this basic file not found exception. So now here's the solution with the try catch block. You put the file input stream, you know, you create your new file input stream, or your new instance of it, your new object. And then you put these in the try catch block. If it can't find the text file, it's going to catch that file not found exception, and then you can put out a custom error message, so it's a little more user friendly. That's something that you can understand. The file is not present in a given path. Okay. And then you can do a similar thing with the throw method here. Here's their example of what it's of the code without the throw. Oh, no, I'm sorry. That's not right. This is where you declare where the throw keyword is placed. So like in this example here, the try is trying out this, it's trying to find this new file, and then an exception gets thrown and it's caught here. but you need to put this throws IOE exception or whatever exception you wanna reference here in order for it to actually get caught, or where you want it to get caught. Okay, now an unchecked exception is one like this example. This one's kind of cool because this is pretty much deals with the assignment this week. So what this guy's doing is he's creating a variable or a new instance of the scanner object to get input from the user. And then he's putting in user input in an integer into a number or into the num1. And then he's putting in another one into num2. And then he divides by 2 and it works, right? So he puts in 20, or no, he puts in 20, divides by 10, and he gets 2. And that is done here with his result equals num1 divided by num2. So if he divides by 0, which is what is shown here, this exception is thrown. And it's an arithmetic exception. So to resolve that, I just put it in a try catch block, which is pretty nice. So system.out.println 12 divided by 0. And then it's gonna fail, obviously, because you can't divide by 0. And it catches the arithmetic exception and puts exception plus get message, which goes to another method. And then there's the multiple catches, and there's also a finally word, a finally key phrase or whatever you want to call it that is connected with the try and catch block, but I'm not going to go into that at this point. Interesting, but it's good to know about it. So it can go try, catch, and then finally, if you want to do additional work after the exception happens. So, in fact, let's just take a look at that. Let's try that on our own here. We'll do a system out print line, and we'll do 12 divided by 0, and we'll run that. Let's see what happens. Oh, I can't run it. Why can't I run it? Did it work? There we go. There's the method. There's the exception. Arithmetic exception. Cannot divide by 0. So if we want that to work, we'd have to divide by 2 and run it. Hello. There. And our output is 6. But since we got to divide by 0, we can put that in a try. Put it in the brackets, do catch. And we know it's an arithmetic exception. Now, I'm not exactly about, does anybody know why they put these letters here?
I think if you want to like print it out, like to see what's going to print out, you could use that.
Oh, okay.
And
cool.
you could do like a system printout AE, and it will print out your catch. I think.
Oh. So could we do that here in the catch zone? Could we do like a system.out. And do a AE?
I really don't know, but I think.
Let's try it. We'll do a is an error message. And we'll plus AE, and we'll see what happens. Try running that. Yeah, it did it. You see that there? If we didn't put the AE in there, it wouldn't put that same error message. So that's cool. Thanks, Omar. Answered my question.
Nice.
Okay. So, all right, let's move on here. That's pretty much it on the exception handling as far as I'm aware up to this point. It's pretty cool. Yeah.
You said we can instead of use the try and the catch, we can use a throw new exception directly in the method.
Yeah, you want to try that?
Yeah, please.
You want to check that out? Okay, let me see. Should be able to pull up some example code on that. Well, I think I can remember how to do it. So we'll get rid of our try catch here. Get rid of all that. And we'll do a throw. Equals. Wait, no, that's not right. Let me see if I can find that. Yeah. Oh, wait, that's the same one. Dang it.
Is it throw new exception with a message?
Yes. There it is right there. Throw new. Yeah, that's what we want. Throw new. We'll do a etiquette. Can we do it like this?
That's right.
No, that doesn't work. What does it want? Method contract to print. No, I don't know what that is. Maybe we don't need this.
Do you already have the throw throws it right above?
Yeah. Okay. Well, that's what we've got. Like this one. Put that up there. and then we'll put divider 12 and 0. Still doesn't like that, huh? Why doesn't it like my import?
I think it has to be on the top.
Yes, outside the
Oh yeah, you're
class.
right. Yep. Thanks, guys. And then
Also found that if you hover over it, it'll say, do you want to add this? Do you want to import this? And you click on it, and it just adds automatically.
oh, gotcha.
In mine, anyway. I don't know.
So I wonder why it's having problems here. Let's see what happens if I try to run it. Should give me some error. To Java language string. Oh, okay. It's looking for a string and I'm giving it an integer. That's funny. All right, so this. Let's try running that. So there it is. It just threw that exception. And it put at the custom error message that we put in. This is an error. So that's the deal, or at least the syntax. You can combine that with like an if statement. So like if, let's say int num gets 1, if num less than, oh no, greater than 0, then do this. Oh, dang it. Okay. Cut. Paste. So since 1 is less than 0, it's going to do that. It's going to throw that exception, which is kind of an interesting way to do it. But so that's the syntax, though.
Cool.
So, okay, let's move on to this data validation. This is we're going to talk about what data needs to be validated. And this is by no means a comprehensive list. There's some things that I thought of. Any data that needs a specific format, type, or range, or any other type of requirements in order to perform future operations within the program. Sometimes it's user input, like if a program's running and it's asking the user for certain types of information. That is a really popular way that data is data that needs to be validated, because the users can often put things in wrong, and it can that can help avoid throwing exception errors. Options for data validation. Some are built into the Java itself, like scanner.hasNextInt. It automatically offers some initial validation right there, because it's going to throw an exception when you run that that method if it's not an integer. If it's a string, it's going to let you know that this data, this type does not match up. So you get some validation opportunity right away. If statements can be helpful in smaller situations, but then there's ideas like the validation classes and chain of responsibility that I don't quite understand just yet. And those are bigger strategies for data validation when you're dealing with like lots of data or in complex requirements. Let's see. Let's try the scanner class and see if we can get some user input. So we go scanner sc gets new scanner, and we want system.in. And then we go sc, no, then we need a new variable. So we'll say integer of input. Sc dot has next int. Oh, okay. No, I don't want to do that one. We'll do the next int. And then we'll just put that out to the screen. System dot out that. Okay, and it's gonna output. It's gonna out input. Let's try running that. So it's waiting for user input, and I put in 1, and then it printed 1. But what happens if I put in a string? It throws the this exception, input mismatch exception. So you could use an if statement to try and like fix that. You could also, if you want it to be a string, you can try converting it to a string. There's a bunch of different techniques that you can do. This idea with the chain of responsibility is pretty interesting. Does anybody have anything that they've kind of used to understand this better? Maybe a link or something that you guys have with that idea?
I don't.
Okay. All right. Well, maybe that's something we should do as a team is maybe find some, if anybody finds a good source, put it in the Slack so everybody can know, you know. Okay. So
What do you know? What do we have to have this week? I just started looking at it. I've been busy on other things.
yeah, no
we
problem.
have to have
Let's see.
an example of all of these.
No, we don't. That's a good idea, Mitch. Let's look at that right now. A second. At least it doesn't specifically say that you do. I don't know. All it says is create a program that inputs 2 numbers from the keyboard in its main method and then calls the method below to calculate.
Okay.
And then you write a method that divides num1 and num2 and returns the results and has the throws clause of most specific exception possible. And I'm doing that with this method right here, my divider method. And I believe that the closest exception possible is this arithmetic exception, because that's the one thrown when it, like the runtime error, that's the runtime error that it gives if you try to divide by 0. And then it wants the try catch block and display a descriptive message. And then it wants you to be able to, the user to retry, like maybe, you know, give the user a chance to not put in 0. And then it wants the output with the numerator is used. And this part I'm confused about. Rewrite the data collection so that it uses data validation to ensure an error does not occur. If a user does type a 0 in the denominator, display message and give the user a chance to retry.
So, quick question here. Have you guys tried, instead of using an integer, putting a double in instead?
I have, and the output gives me infinity.
Yeah. So I did more reading on that. Java actually processes doubles differently than integers and allows you to have 0 in the denominator when you're using doubles.
Awesome. That's cool.
So
it doesn't say you can't do that.
Based on what he's saying here, I'm guessing he wants us to use integers since he's using 0 in the denominator as an example.
Yeah, that's kind of what I was.
So it throws an error.
Right.
What if a more robust program and a more specific exception would be simply if the only possible exception is a string or something put in there other than an integer or a double?
So what do you mean?
So where he says most specific exception possible.
Yeah. Okay.
What if there is one that's more specific than that? If you can eliminate the possibility of an arithmetic exception.
Oh. With a double?
Yep.
Well, it should.
I'm just throwing out random ideas. I don't know.
Oh yeah, I got you. But it should, if there's no exception, if it doesn't throw an exception, like what would the exception
is if a string was passed to the double instead of a double.
Oh, I see what you're saying. So it would have to be a totally, like, right, I got you. Instead of a data type that deals with numbers, a data type that deals with string values. Or could you, in that situation, couldn't you even just say, like, maybe it's a Boolean value?
Yeah, you could say.
Or a data type of anything
anything
other
that's
thing?
not or doesn't fit the data type of a double. Would still throw an exception for it.
Yeah.
But that's a double's pretty open compared to an integer.
Yeah. Good point.
I think you can have more than 2 catches.
You can't.
In one try, I believe. So, for example, you can have a catch for an arithmetic, and you can have a catch for, like, for example, you put like a string, and you put a message like enter. You have to enter numbers or something.
Yeah, they have an example of that here. Here it is. They do a catch for the arithmetic exception, a catch for the array out of bounds, and then just a standard exception for any other type of exception. So you could do something like that. It's a good idea, Omar. I don't know if the assignment's really asking for that. I don't know. It doesn't say what type of data type to use. So, but I did try working it with a double, and I was getting that infinity stuff. So I went for the integer. Go ahead, Omar.
I had the same problem with the double.
Yeah.
Also for the program, if it catches the error, you have to make it so that it gives you another chance to type in again.
Hello? Hello?
Hey,
Can you hear me?
yeah.
Sorry, my audio cut out there for a second. What did you say, Omar?
Oh, so for the program for week 3, let's say if it catches the, let's say you make it catches the error, you have to make it so that it gives you another try.
Yeah. That's the way I read it. Uh-oh, where'd Samuel go?
Oh, he said that he had to go.
He's gotta go.
Yeah, he had to go.
Okay, no problem.
Yeah.
He brings up an interesting point with that double. And I'm not exactly sure. I'm just going on the premise that we're dealing with integers because the infinity doesn't throw any exception.
Yeah, I think he
But-
wanted to throw an exception and deal with it.
Yeah.
Yeah, but like also when you divide, let's say 5 divided by 2 is gonna give you a double.
Right.
So I was thinking about that too. So I just went with integer, and I tried doing the result as double, but it doesn't work.
What does it
So-
do?
I think it just says like it gives you 0.0. So I just went,
0.0?
yeah, I just went with integer.
Really? Mine just does 2. It just goes to the
Yeah,
nearest whole number.
guess, yeah. But
That's kind of cool that it rounds it to the nearest whole number. I like that. Well, if you guys use some other data type other than int, and you come up with a more specific exception than this arithmetic exception, let me know. Because maybe I got this all wrong, but I think this is the arithmetic exception is what we're talking about.
Yeah, I think so too.
Anyway, so we can, I'll wrap up here. And then if you guys want to keep talking about the assignment for this week, we can do that. Check exceptions are forced to handle by a compiler, so you can't even compile the program. You can't even run it at that point. Unchecked exceptions are not forced by a compiler and will happen at runtime. So you can run it and it will throw that exception. And if you don't handle it in a good way, it'll just, it'll throw the exception in your program. Validating data can help avoid exceptions being thrown. You can kind of control a little bit on how that works. And some situations, the Java has built-in tools that can help with the validation, and like if statements and the has int or next int and stuff like that, and next string or next line. And more complex situations, grander strategies should be implemented. So that's all I've got, guys. I hope we covered some good ground.
Yeah, that was good.
Went a little long, but we did work through some problems together and stuff. So that was good. Thanks, everybody. Good job. So is that the only question everybody has about the
yeah, it's all good.
program? Yeah.
Yeah.
Thank you.
Good.
All right. All right. Sounds good, guys. And we will see y'all later.
Okay, see you next week, unless we
All right.
need to sooner.
Yeah.
Okay, bye.
Talk to you guys later. Bye-bye.
Bye.